how I've been designing applications in the past few years. I tried that approach in a few different projects. By no means I'm saying that this works for every single project, because I don't know. I tried in some projects and it worked well for us, but I don't know your context, I don't know the type of software that you write. So what I want to do is to share what I've been doing, and then you need to say, oh, this applies to us, this doesn't apply to us. But one of the main things, what I've been trying to achieve, do you guys do Java development? How many of you do Java? Oh, whole room, okay, so that's all right, easier. So, PHP as well? Okay, that should apply as well. So I've been doing that mainly in Java and Scala, but I don't really think that it matters. So what I was always trying to achieve, since I started with Java, that was a long, long time ago, was if I was looking at my application from above, how I would like to be able to tell what it's about and what it does very quickly. If you're a new guy joining a project and you need to quickly find your way around, you need to figure out like what does it do, what it's about, and then find the place that you want to change. That's what I wanted to see very quickly, just looking from above. I tried many different types of design, and I always struggled with this. I could not see what the application is about, mainly because like a lot of architectural and design concepts were mixed with the domain. So when you look at loads of applications that at least that I worked in the past, I would see services, factories, view model, but I just couldn't see. So, and then all of a sudden there was some bits of domain in here and there, but I could see architecture, but not what the application was about. We normally pay attention to classes and methods, but very rarely I see teams, and I include myself in it, that I go there and I refactor the entire package structure or even split modules. Very rarely you take a refactor to kind of almost like a redesign or refactoring at a much larger scale. And also when I want to change something or add a new feature, if I'm new to the team, new to the project, I have no idea where to start. So this is one of the, how many of you organize your package structures similar to this? Because I've done that a lot. So a few. So I've done this a lot, and the problem is I can see controllers, DAO, factories, helpers, model, page object, or yeah, I can see layers, I can see design, I can see maybe some architecture, but I have no idea what this application does or what it's about. So what was missing there was some domain concepts. And then you go there and start introducing like book and user, and then it doesn't matter where you put, on which side you put. You always have this duplication, because now you have some domain in there. You say, okay, this application is about books. It's about users. But what does it do? Who are these users? Are they users buying books? They are the authors of the book? They are people commenting on the books? So what do I do with these books? Do we do a book review? Do we sell books? I have no idea. Right? And then we have all these things. So I know what it's about, but I have no idea what it does. And another way of structuring it is the traditional MVC as well. So now, this is a web app. Yeah, so what? But what does it do? What it's about? So I tried many different combinations over the years, and I could never get there. Right, so I guess I'm reaching a point where I'm slightly happier. How many of you are happy with your package structure? Ray, no one. So yeah, one guy once said, no, I'm very happy. And so like, okay, did you do it yourself? Was it you that defined? So yes. So is anyone else happy in the team? No. So it's very difficult to model your application like that. So before I get to I'll show you how I'm doing that today, I'm gonna explain to you my thought process, what led me to what I'm doing today, and hopefully this will help you. Once again, this is not a prescription, this is not something that you can apply everywhere, this is what's been working for me, so just make it very clear, because I don't like speakers that go there, you should do that because it works everywhere. I don't know, it's working for us, right? So, but I'll take you to the thought process, everything that we took into consideration to get to where we are, and then if you want to expand on that, at least you know what we thought about. And I will need to start with MVC. And so MVC goes back to the late 70s and in Smalltalk, but just became a general concept in the 80s, late 80s. And from there were loads of different high-level design, if you like, the 3-tier architecture. And then in the Java world, we had Model 1 and Model 2 MVC, mainly when that was late 90s, early 2000s with JSPs and servlets. We're trying to bring MVC to the web. And then after that, there were loads of variations, right? MVA, MVP, MVVM, very popular in the .NET world, and many other things. So what I've seen many different type of implementations or variations of MVC, but the vast majority of them, and I did it myself, bad implementations, led to this thing. So we know what view means. But then we say, okay, so what is model? And then we end up having our model representing the entities and things that we persist. And that leads to anemic domain, because if you just talk about entities, what about the behavior of the application? Because the entities, they are a static representation of your data normally. So, and then we end up putting behavior on the controllers. And that's what I normally see. It's very coupled with the MVC framework. Fat controllers, because that's where people say, like, if my model are the entities, my view are the pages or forms or whatever, then they don't have a place to put behavior, and that's how you see a lot of controllers having all the business logic, where it should have just a single line of code, or a couple at least. So all these MVC variations, they are good and bad at the same time. It depends on the view, right? So the view is what should dictate what the MVC framework flavor you should use. I'll give you a few examples. So there are many different types of applications out there. So for example, you have like the traditional web app that is just like forms, and then you click links to go to the next page. It's not very rich. So the more traditional web applications, the view is on the page, of course, but the controller is on the server side. It's under your MVC framework, being Spring MVC, Rails, Scalatra, whatever you do. But if you have a single page application or more modern, richer application on the client, your controller shifts from the server to the client. You have a lot of JavaScript going on, and JavaScript in the client will do a lot of the controlling and just consuming data from the service with a stateless backend normally. But it changed. In a console-based application, that's what I'm working at the moment, by the way. So I have a desktop application written in Java with JavaFX. So the MVC is very different, because each component in the screen has its own MVC embedded. Each button, each combo box, each data grid, they have their own MVC embedded. And it's across your entire application. So desktop I was talking about, in fact. And then console-based applications, what is the view is your console. So where's your controller? How do you model that? So there are many, and then mobiles and external systems, or you could even see external systems consuming data from you as sort of the view. If you have a service architecture, a service-oriented architecture, your controller is even above everything. So I think that MVC is a macro pattern. The way that I see it is MVC is a macro pattern. So the V and the C, the view and the controller, this is what Uncle Bob, I think that he finally got a term that I really, really liked it, that expressed this very well. Uncle Bob calls this the delivery mechanism. It's how you deliver your application. So you have, like, if it's a mobile app, if it's a web app, if it's a desktop application, that's your delivery. That's how you deliver the behavior of our application to the external world, to a user, to another system. And then, so that's where the MVC will vary, the MVC implementation you have. The question is, what is this? Model is a difficult one. So model is very confusing when you talk about model. What is model? So a lot of people say, oh, it's the model in MVC. Right, yes, sure. But is it how do we model? Is it the domain model in domain-driven design? Or is it view model, data model, entities and active records? Is it what you persist? It's very confusing. I believe I like to use my model as the domain-driven design, what they call the core domain. That's for me is model. So in domain-driven design, the domain model is about behavior and state. Because no one, normally when people ask you to do things, like the product owners, project managers, when they are asking for us to build a system, they don't want us, they are not asking, I want you to store the address in the database. They don't ask for data in the database. They ask for behavior. I want to provide a mechanism for users to buy books. I want to provide a way to put comments. I want to provide someone that could purchase or buy something from. They are interested in behavior, right? And then they will do something with the data as well. But the features normally they are about behavior, and that's what the model should be about. So in domain, how many of you are familiar with domain-driven design? A few hands. Okay. So domain-driven design has a few building blocks. Domain-driven design is a huge topic, and the best thing about domain-driven design are not the building blocks, but that's what I'm going to talk about here today. Well, part of it. So there are a few building blocks that they use. Entities. Entities are things that you have an identity that represent a domain concept, like a user, a book. Value objects are data that qualifies a domain concept. For example, a book may have a type, and this type can be fantasy, can be technical book, so that adds information to the main entity. Or is a color, is a chair that is red, so that's a value object. You are not worried about the identity, you just care what it is. There are situations where an address, is it a value object or an entity? There's always this discussion. It depends. It depends on what you are doing, right? So if you live in the same house, so let's say that we both live in the same house, and we are buying stuff from online. So when we put our address, this company, they just care that they are going to deliver that thing to that address. But they don't care about the identity of the address. I can put the same address, you can use the same address. So in this case, it's a value object. But if you're talking about a utility company where they deliver the gas, electricity to your computer, telephone, so the address is the main entity. That's what, it doesn't matter who lives there. So that's when it becomes an entity. So factory are used to create big domain, big object graphs, aggregates, I'll get there. The repositories are normally contain the data that you need to perform your behavior. Services, there are three types: application, domain, and infrastructure. Normally application services are the ones that will control the flow of the application. So when something happens, it will control the flow. Domain services are normally just take care about one part of your domain, like books, users and stuff like that. And infrastructure is whatever is not related to your core domain but is needed. You need to send an email out. You need to have a web service call. Those are infrastructure services. And aggregates normally are, for example, a user has friends, has a profile. This could be all in the same aggregate, and where the user is the root, and then it has dependencies in there. I won't go, like there's 2 huge books on the topic, so you can read. So I think that's what I was trying to say is, for me, the M is the whole domain model, is where the behavior is. And that's how I prefer to see it. And the delivery mechanism is separate. When we have this separation, designing your application with this in mind, where this is how you're going to deliver something, and this is what's going to provide the value, what people want. When you think you start designing your system like that, you start having options. Options, for example, if you are starting a project from scratch and it's still very small, you can take, let's say that you are doing a web app, you can bundle everything together. You just create one deployable, a WAR file in Java or something like that, where the delivery mechanism and domain model is together, the same deployable. You go live with a single file, put it in there. Normally, the infrastructure will be segregated as well. So there is infrastructure for the delivery mechanism, there is infrastructure for the domain. This should be separate as well. But once you, yes?
How far does the entity goes? Because most probably you have some entities that will cross the black line to go to the...
Let me try to get to the end. I may answer your question. If I don't, I'll answer later. Yeah. So When you have this separation, you have options, as I said. While you are at the beginning, you can deploy everything together. But if that separation was clear, what you can do, you can wrap your domain with some infrastructure layer and have it deployable separately on its own. And then you can just have different delivery mechanisms accessing that. So you could even have an event-based system as well. It doesn't matter anymore. Once you have that, the separation, it's just a matter of wrapping this. And this is some of the guys in domain-driven design and a few other, the Goose guys, they also talking about ports and adapters. I think that someone is going to be talking about that today later on. But that's where your ports and adapters would live, in these boundaries here, right? Providing ways for the external world to connect to your domain. Let's talk a little bit what is inside. And that's how when I start deviating a little bit from domain-driven design. I'm a big fan of domain-driven design, by the way, but there are things mainly on the blocks and stuff that I struggle with, and I prefer to do in a different way. So the way I see it is, when you have the domain model, you need to provide entry points. And that's what I call actions. In domain-driven design, this would be an application service. I prefer to call them actions. Actions is, you define the way, for example, you have a payment. You have some items in your shopping basket and you want to pay. So they represent the behavior of your application. Someone in your features, in your user stories, they want to say, I want to make a payment, I want to buy something. That's what these guys are. They're make a payment, add book to, search for a book, add book to shopping cart. They are all the actions, all the events that your domain is providing to the external world. So they are the entry points to your domain. That's how I prefer to see it. Then you have a layer of domain services. Domain services have a smaller scope. They will talk about, sometimes you perform an action. Let's say that you make a payment, but to make a payment you need to validate the user account. You need to know if the user has a Prime account. You need to go to the payment gateway. You need to validate the credit card. You need to send an email confirmation. There are loads of steps to perform so I can make a payment. And all these steps, they may belong to different parts of your domain. And that's what the domain service will be about. Everything that is related to the user, go there. Everything that belongs to book, go there, and so on and so forth. Repositories will deal with the data. You can have some other classes. A few things, and then you have infrastructure services. The repositories and infrastructure services are interesting because if you're in the Java world, C# world, the interfaces, they belong to your domain. The implementation belongs to your infrastructure. So from my domain perspective, I need to find a book by title. And that's this guy here is responsible to do that. The interface say, I can provide you this service. But the implementation can be a MongoDB repository, can be an Oracle repository, a Gigaspace repository, it doesn't matter. So in domain, I'm just worried about the behavior. So entities, that's where I deviate a lot from domain-driven design. A lot of people, when they talk about domain model, and I've done that a lot in the past myself, they talk about entities. They start modeling let's model our domain. They start with entities. So we need a user, we need an address, we need books, and we need this and that. Right, but how we are defining this data structure to satisfy which behavior? So in my view, a domain model we should start to design a domain model according to the behavior that we expect from our system. And then the data structure will emerge to satisfy that behavior and not the other way around. So the actions define the actions that the behavior that our system is going to perform. So everything that controls the flow, all those steps that I was talking about, it will be on the action. The action is controlling flow. It doesn't do any specific itself. It delegates, controls flow. Domain service, the logic in there is related to a specific domain. So in the entity, not always they are simple dummy data structures. So, but I'm very careful with the behavior that I put it in here, and that's why domain-driven design and what I'm doing is quite different. The behavior that I put inside the entity is just the behavior that is related to the data that the entity contains. So if I want to know if someone is underage or above age for certain thing, I will have in the entity because it's just related to the data. So loads of things that are related to the data that entity contains will be there. But if the behavior is about multiple instances of the same entity or instances of different entities or needs to go to database and web service, that will never be in the entity. So that's how I prefer to do it. So I don't have entities as my centerpiece in my domain. Repositories, I'm naming them in a slightly different way. I take the domain concept. I try as much as I can not to use repository service actions in the name of the classes. Not always I'm successful, mainly with services. Sometimes it's very difficult not to use service. But in the repositories, for example, if I have a user domain concept, I'll call my interface as users. But if I have books, it depends. It depends on how the domain people will use the term. Some of them will use library, some of them will use bookshelf, some of them will use book collection. I will use the name that domain experts will use. I'll give you an example. So that's how roughly how that works. I have an action called make a payment, and then to satisfy, I say pay on the browser, submitting all my personal details and payment details. So that will go to a domain service that will validate the user account, figure out if it's Prime, come back, then it goes to the payment gateway. Don't get too worried about this. Is just an example, because I would probably design this coming the email sender from here, but it's just an example how these things would fit together. I may need to retrieve some data, so go to the repository. Payment gateway may talk to a payment validator, that is a normal class, or an interface, that is a card processor. So the interface card processor is part of my domain. The implementations, that is Visa, MasterCard, and everything else would be infrastructure. I can just plug these things in later on. And then another service. So domain services can talk to each other to perform actions. And then send an email out. But that's roughly how things. The interesting thing is, this guy here is very imperative. The code inside it is not very OO, and neither is functional. It's very imperative. And that's okay. This purism sometimes is bad. You should use what it fits best. I use a lot of solid concepts to design all of this. But if I need to have some imperative code here, I will have. And I will have functional wherever it fits. And good OO design whenever it fits. Because this guy here is controlling the flow. And the reason that is imperative, because when we get a user story, you have an acceptance criteria. Acceptance criteria is bullet points of everything that you need to do to satisfy that user story, that behavior. And you need to control that. And that, by default, is imperative. You need to validate the user account, you need to see if it's Prime, you need to make a payment, and you need to send an email. So this guy will be slightly more imperative. You use all the clean code in there, have a small method, extracting methods to private methods, good naming, sometimes even extracting class. You do all the good code, but it's more imperative. And that's okay. From here is more OO and functional, depending on where you are. There are this a very interesting thing that I noticed is you have an input to your system that can be a message in a queue, can be a button from a page or something like that. So there is an input, something that will trigger your system, sending some data or asking for some information. And then loads of good stuff is going to happen. And at some point you have a side effect or an output, right? So what I noticed was the closer the classes are to the input of the application, they represent a higher level of abstraction, right? The closer they are to the output of your application or to the side effect or to the end of a branch, because a code will come, there is a branch, and that may come back and rejoin the main branch and do some things. So if closer to the end of a branch or to the output, the more specific, more low level. So for example, this guy here, the method is about process a trade. This will trigger an entire enterprise application to satisfy process trade. The same way that I make a payment will trigger a lot of things. It's a much bigger concept, higher level concept. While when it comes to here, you say, insert this user, find this book by ID. It will be parse this part of the XML. So the concepts are different. Which means that when you are talking about TDD, and that stupid discussion if TDD is dead or not, because that was stupid in my view, I'm sorry, and when to use mocks and not to use mocks, it depends on what I'm doing, it depends on the responsibility of each class. Normally, if my classes are on this side, the responsibility of this class is to coordinate flows, which means that it will collaborate with a lot of classes, or at least some classes. So in this case, if I'm testing this class, because the behavior of this class is collaboration and controlling flow, of course I will use mocks, because that's how you test collaboration. If my classes are towards this end, and I won't use mocks, unless that they are going out. Then I will have a small layer here and mock my class. But that's normally, so when you say classicist, mockist, London school, I don't care. What is this class about? What is the responsibility that I'm trying to test? And I'm going to use the TDD style that fits better for that class. That's how it works. So a few tips is, I never have actions talking to actions. Every time that I had the need to have, so this is what I'm exposing to the external world, right? Those are the controllers or the external world, the delivery mechanism, or someone asking for something. Every time that I had a need to go for this one to reuse something in here, normally is because there was a domain concept missing. Every time that you are trying to do something that doesn't really fit, or you need to reuse in a very odd way, it doesn't feel bad, normally it's because there is a domain concept missing. You need to figure out what it is and extract that and make it a proper domain concept. And then you reuse. So you are introducing your domain like that. So normally an action we talk to as domain services, if it's talking to, that's normal good OO practice. If a class is talking to too many collaborators, the discussion is what is too many. For me, like 2, 3 is already too much, but I don't use fixed rules. So there's always a good reason to break a rule. So then you are going to start introducing. So if this was talking to 5 different classes, once again, there is a domain concept missing. Maybe there is something that should be in front of some of them, and that would delegate further. So action talks to domain services. Another thing that I deviate from domain-driven design in terms of building blocks, I don't treat repositories as first-class citizens. I think that repositories for me are just a helper to my domain services. I don't allow domain services crossing like that, because a domain service can be composed by many classes. I don't want different modules or different domain concepts knowing too much about the domain. So I want to reduce the coupling between my domain concepts. So the entry point to a domain concept is always here. If this is providing too many methods, once again, there is a domain concept missing. You need to split that, figure out what it is. And then they can talk. So a repository almost for me is a helper to my domain, with the exception of this that I'm talking about now. How many of you have heard about CQRS, Command and Query Responsibility Segregation? Few people, probably the same people that know about domain-driven design. This is a way that I find fascinating when I tried. Comes with challenges as well. Is normally we go for a single domain model. How many of you use Hibernate or any ORM tool? Many of you. So the problem that we have with these ones is that all the entities in our application are connected. So imagine the scenario. I'm a user, I have a profile, I have friends, I have trips. Each trip has days. Each day has locations. I can go to more than one location the same day. Each location has photos. Each photos has comments. The comments are made by people that have friends. And then each screen, each report, I connected my entire domain, but when I want to see just a list of my friends, just my profile, or just comment on a photo, what do I bring to memory? The entire database? Probably, of course not. So then we start feeling, oh, what is eager load, lazy load, eager fetch, and all this kind of stuff. What do I bring to memory? And start all this nonsense, all this madness. Because you need, and it doesn't matter how strategy you want, because there will be a new feature that will go across again, and then so I have a different cut now. So this helps with this. So what this is doing to avoid this mess, the only time that you need these entities to be connected is when you are reading. So when you are doing your queries, you need to join all these things together. But when you are writing, creating, deleting, updating, you never delete a photo together with everyone that commented or liked it, or you normally do one domain at a time. So you can afford to split your write model with almost no relationship. So every write goes through here, the entities are decoupled, and you just do that operation. And then, once that operation is done, what you can do, you can throw an event and say, a user was created, a trip was created, or there was a comment in a photo. So that throws an event. The read model will capture that event. Oh, there was a change in the data, in the domain. So I'm gonna take that change and store it in the way I want to display it. So you can have multiple listeners to that, and then provide just a repository. It's almost like creating a view, a snapshot. So you have a page that gets a bunch of data. You can create a view for that. That's exactly what this is doing. So with that, you have a very simple code in here, no relationship. And here is just say, I want this view of my data. Single call, go to a database. That can be a normal relational database, can be a document, can be whatever you want. So you can plug it, whatever listener. And if that information is better served in a document, in MongoDB, yeah, so be it. So you decouple the two. So I think that this is a great way. Both sides are extremely simple. So I said all of that. So those are things that I considered to get to where I wanted. So how I'm structuring today. If you're starting a very simple project, early days, there's no need to start creating Maven modules and separating everything. No need. Just simple package structure will do the trick. And that's how normally I start. I create one for my domain and one for my delivery mechanism. So my web would be my delivery mechanism. The other one would be my domain model. Just different packages. That's it. It's good enough. So when I open it, let's start with the web. We'll have all the web related things. This is not the most important thing, because your delivery mechanism can be different. But just to give an example, here I'll have my controllers, my view, my infrastructure to parse JSON or XML, whatever you do in the view. And then here I will have just infrastructure, model, and actions. Those are my three top packages. So for the web, controller should have one line. The role of a controller is there is a request from outside. Let's say there's the view. This controller already knows what it is because you map that action to a controller. The controller says, okay, someone wants this behavior, model. So the controller goes there, invoke that action that you triggered, all that good stuff. Comes back to the controller, say, that's done, that's the result. Controller redirects to a view. That's the role of controller. 2-3 lines, tops. And then infrastructure, as I said, they can have the parsers if you need, and view models, and you can have all this sort of good stuff. But the cool thing is about here. So in a simple project, inside my model, that's what I wanted to do, like looking from above. That's my top 3 packages. I open this one, I have book and users. Those are my 2 packages. I already start seeing what this application is about. My actions, I will put it in here. I'll name them after verbs, after what is the expected behavior from my system. So add book to wish list, search books, update user. So just looking from here, I know roughly what this application is about and what it does with that information. So, but of course, applications don't get that small. They grow. So while I had books, I now have electronics. So then I go to my domain expert and say, right, now we are dealing with electronics as well. Is that a super... How do you group them together? We call it them products. Okay, we refactor the packages and put projects in. And then we have payment and we have user. So for those of you that are more aware of domain-driven design, there is a concept called bounded contexts. So as you start adding new behavior in your system, always naming them after verbs. So find recommendations, search books, add books to wish list. So you can start grouping them, because normally these user stories become, they are part of an epic, or they can be grouped by features. So you can start creating these modules, products, purchase, user accounts, and according to epics and themes, or let's call it capabilities, like Liz Keogh. She would be happy that I mentioned that. So that Liz Keogh is now using as capabilities. So they are the capabilities provided by our system. So you can group them like that, and those are candidates in the future for bounded context. If you want to split our application, if you want to go microservices and all this kind of good stuff, those are a good split, because they are business split. You are not architectural split, because that won't work. So you have a clear way of doing that. So one of the things that I've done, I removed all the layering, all the design from my packages, because from a business perspective it means nothing. Having services, DAOs, means nothing to the business. So I put them all together. So my entities in here, my repository, book service, all of them are under book. There's no need to map layering. Layering just makes sense to developers. That's how we see the world, but that's not the right vision. We should design according to the business modules, and then everything that is related to book is here. Instead of spread, oh, my book entity is one package, my book service is another one, my book repository is another one. That doesn't make sense. So that's how it looks like inside. On the infrastructure side, how I'm doing for time. In the infrastructure side, then I can have the implementation of things. So in the repositories, then I'll put all together, because at this point it doesn't matter. It makes more sense. I'm plugging the repositories into my system. So all my Gigaspace users, my MongoDB book collection, all my credit cards, processors. So all these things, but in my model, for example, credit card processor is an interface, email sender is an interface, and the implementations are here. Even in infrastructure like book to JSON, user to XML, things like that, there's all infrastructure, that all lives outside. So, right, how do you test that? Right, that's always a good. The problem is like defining your tests. We had enormous debates, like a full day discussing, is it a unit, is it a component, is it a system, is it an application, is it integration, God knows what the hell it is. So if you try to Google for types of tests, you will find loads, like tens of them. And in each source, each website, they will define them differently. What it's described as a component test in one of the websites is described as an integration test on the other, and an application test on the other. And so we said, like, forget that. What we've done was, because now we have a kind of a high-level design, we went to the whiteboard, and that's what I suggest to everyone. Go to the whiteboard. Put a big box, that's your application. Roughly, those are the pieces that you have. Take a pen, dot an area, create a boundary. Say, I want to test my user journey. Means I want to test that the user can click and navigate through these pages. I don't need my entire backend. Because I have the actions now, I can mock all of them or fake all of them. So this is a area, a boundary, and we say which name. So first of all, we define what is the boundary, which piece of the system that we want to test in isolation, and then we chose a name to it, a name that it makes sense to our team. Well, we call it user journey. So the application can be tested as a black box in this way with all your BDD framework. Right, if you use Cucumber JVM, JBehave, or SpecFlowing.net, and all these things. And so you can fire that just putting fakes. If you have like an embedded Jetty, that helps a lot. So just fire that instead of deploying in Tomcat and stuff like that. So you can test the entire thing with fakes. And then, for example, we wanted to test a full behavior. Make a payment. Is it doing everything it needs to do? So I could start my test from here. There's no need to have the entire application with the web in there. Because that's my entry point. As long as I pass the right parameters in here, that should trigger. The only thing that I want to mock now is the external world, is when it's going out. So for this one, we call it acceptance test or action test. So we normally call acceptance test. In our case, that's the name that we gave. Give whatever name you want, it fits best. This is also can be tested with a BDD framework. if you are using one of them. So what we wanted, but of course we want to test our queries as well. Are we sending the right queries to the database or to the grid or whatever? So then that's what we call integration. Integration for us, that's the boundary that we drew, and is all about putting a in-memory database or even a real MySQL or whatever, and then run these tests. Just make sure that I'm sending the right data, right queries, right data when I'm doing certs. And that's integration for us. And then the unit tests. We normally do outside-in tests, so we use mocks normally. But as I said, we use when it makes sense. And this big box, that is the end-to-end, the full application where it's deployed. We have a handful of them. You just need the sunny day scenarios for a few main features, just to make sure that everything is wired together. Everything else was tested at a lower level. Very few, so this should run in minutes as well. One interesting thing, that's what I'm calling the interaction-driven design, this style, is there is execution flow, and that's the same flow that I use for design. The design flow follows the execution flow. The way I do this is outside-in TDD, that's outside-in design. So the way I design a class should never be designed in isolation. If you design a class in isolation, this is a selfish class. I said, I'm very important, I want to provide this behavior. I don't know how people are going to use it or other classes, but I don't care. And that's when you start having weird, because that's normally when you start from inside. So you instead of following this flow, you design like, oh, I think that I need this service, I think that I need this parser, I think that I need this. And you unit test everything, but then when you want to put the behavior around, it just squares, it doesn't fit properly. So normally the way I prefer is like, there is a need. I identify this need. Normally comes from your business specification and the constraints in your delivery mechanism. So there will be a trigger in my system. I need to provide this behavior. So I always design classes from the perspective of who is gonna call the class. Always from the client perspective. So my classes or functions will always be designed specific to that use. So that makes the code and API very easy to read, because every class was designed to help someone or to provide a need, an existing need. So that's normally how I go about design. The entities, as I was saying before, because I'm always thinking about the behavior, so when we are designing like that, you start with a verb. So you are starting with an action. I want this system to do that. Make a payment. Find a book by its author. The data structure will emerge to satisfy this behavior. And that's when I will start creating my entities and things like that. Some of these information will come from the UI. Well, we want to capture this data, we want to display this data. But how this data structure is going to be combined is the behavior that's going to tell me. So, in a nutshell, if I'm looking from above now, I have in my model package, everything named according to nouns. So when you take your business requirement, find nouns. Nouns are candidates for package names and class names as well. For methods, you want the verbs. You want to look at your spec, find the verbs, and those are the names that are going to go in your methods, with the exception of your actions that I normally name them after verbs. And with that, even if I'm a new person to the system, I can very quickly open the system from above, understand what it does, what it's about, and I very easily can navigate to the place that I need to change. And if I need to add something, it's easy for me to understand what the design is. Yeah, I think that that's what I had to say. If you have any questions. All right. Either it totally made sense or anything. I don't know which one was this. Yeah, so book on craftsmanship. Thank you. There was a question.
Speak
about the that I was talking.
It will be more project with a book name Design.
Design is a